In today's lesson, we'll be integrating by substitution, and we'll start with the indefinite integrals. Now, this gives us an alternate method for reversing the chain rule. So there's some questions that we can do with that reverse chain rule method that we've already seen, and we can now choose to substitute. But even more than that, it's going to give us a method that we can integrate some functions that we really couldn't have done any other way. Now, here are the steps that we need to follow. This will make more sense as we look at our first example, but we need to actually define a new variable. So if we've got some function of x and we want to integrate with respect to x, then we define a new variable, and in this course it will generally be given to u. A lot of the time it will be u equals some function of x. Sometimes it might be theta equals some function of x. So what we do with that u is we differentiate it, and then we split the fraction up. So du dx, for example, can be split into a du part and a dx part. You'll see how that happens in a moment. Then we rewrite the thing that we're integrating, that's called the integrand, in terms of the new variable. So if it was in terms of x dx, we rewrite it in terms of u du, so that we've got something a little bit easier to work with. We also rewrite the dx part. So instead of being x dx, it will be some sort of u du. And we actually then simplify it up if we need to. So some of the more complicated ones that you do today will need tidying up before you can integrate them, but that's pretty standard. You never integrate anything unless you've got it as simple as you can get it. Then you'll integrate with respect to your new variable, whether it's u or theta. And then at the end, substitute back, because if you've been asked a question about x and you want to integrate it with respect to x, then you can't have u's and du's in your answer. So of course you'll, at the end, substitute back in whatever u was equal to, so that you've got your integration completed in terms of x. Okay, we'll start with an example that we can actually do using our old method of reversing the chain rule, because then when we do it with our new method, I think it will tie it together. Now we've learnt that with something like this, we can only integrate it, unless we want to expand it out, of course, which we don't want to. We can only integrate something like this, where we've got a function of x raised to a power, if what's out the front is actually the derivative of what's in the brackets, or something that's close, only varying by a constant. And we've learnt to use this formula, which is the very top one on our list of integrals on our reference sheet. It says if we've got f of x raised to some power n, then if we have f dash x out the front, then this is the answer. We just raise our function to a number that's slightly bigger, divide by the new power, and then add a constant. Now, to write this in a different way, if we called f of x u and just said that u was our function of x, then what we need out the front really is du dx, isn't it? And that's why they call this reversing the chain rule, because the chain part is where we differentiate y with respect to u, differentiate u with respect to x. And when we're differentiating, that's the chain, the u part in the middle. So you could write it this way if you like. Now, we're not going to focus on that because this one's not on our reference sheet and it's not what we've considered before, but it sort of leads us into a new way to do this. So our method previously was to say, well, is it a perfect question? And it's not, is it? Because f of x is 1 minus x squared. And if you differentiate that, you get negative 2x. So what we want to do is a question that's got minus 2x out the front there, looking like that. And now we've gone ahead and changed our question. So to allow for that, we need to multiply by negative a half, because the negative times negative will be positive, and half of 2 is 1. So now I've changed my question. I've got a fixed factor out the front, and I've got something that I can easily integrate because it's in this form. So we say we've got negative a half, and then we take our power of x, 1 minus x squared, and we raise it to a number that's slightly bigger, and then we have to divide by the new power and add a constant. Then, of course, tidying up needs to happen because we've got halves here and fifths there. So we can write it more simply, 1 minus x squared to the power of 5 all over 10 plus c, and we're done. Okay, now let's do the exact same question, but this time using substitution. And we've been given a substitution to use. Now there's kind of two parts to the working. You want to keep writing integrals over here until you've actually integrated and you've got your solution. And then on the other side of your page, you can have some side working where you actually do the work that you need to put as your substitution. So I'll tend to write my substitution over here every time and write my actual question on the left. Now, the next step that you need to do over here is sort of 2 steps in one. I'm going to do the 2 steps separately this time, and for the first couple that you do in your textbook, you might want to do it in 2 steps, but you're very quickly, I think, going to be able to do this in 1 step. Now, if we know what u is, and it's in terms of x, then we can find du dx very easily. We just differentiate with respect to x, and we get minus 2x. Now, the next step involves splitting up the du and the dx. Now, it's not technically a fraction, but we can treat it like a fraction and say that du is equal to negative 2x dx. So when you've done quite a few of these, you're going to go from this step to this step just in one go. You'll find yourself leaving this line out. But if it confuses you, feel free to do this line every time, but it's one that you'll very quickly see as a little bit optional. Okay, next we need to look at what we've got over here and what we've got over here and whether we have everything to actually just throw in, because we're trying to change this so that it's all in terms of u. So I can see that this part here is just u to the power of 4, and that leaves me with the x dx part. Now, over here, I know what negative 2x dx is. So in a way, the perfect question over here would be one that has negative 2x dx, because negative 2x dx I know is just du. So in a way, this is sort of an optional line too, but it's one you might like to use in the beginning and then later on leave out. In your mind, you're thinking, I need minus 2x dx because that's what I know is equal to du, and I want to use du. So I've changed my question by multiplying it by negative 2, so I can adjust for that by multiplying it by negative 1/2. And that's the same fixed factor as we used when we did it the other way, remember. So you can see it's actually quite similar. Next step, my negative 1/2 comes along for the ride, and I can make my substitutions. So I'll say, all right, negative 2x dx, that's just du. And this part is just u to the power of 4. So I've really simplified this thing. Now I can say I've got minus 1/2, and if I actually integrate this now, I've got u to the power of 5 over 5, and the integration is now done. Now I could also tidy this up. Obviously these are multiplied, so I've got tenths on the bottom and I've got a negative on the top there. So I've got negative something over 10, but instead of writing u to the power of 5 over 10, I'm going to write down what u is. It's 1 minus x squared in brackets to the power of 5. And now I need to obviously add my constant as well. In fact, I should have done it on that line too. So the steps then are to write down your substitution, differentiate it, but then get du by itself. And if you can go from there to there in one line, awesome. If you can't, just take your steps. Next, compare that to what you have. Can you get rid of the dx by just substituting in, or do you need to fiddle around a little bit more? In some examples, you'll need to do a bit of fiddling. Write your perfect question to get your fixed factor. Make your substitutions so that you should have everything in terms of u du. Then integrate with respect to u, and then substitute in what u is so that you've got your final answer in terms of x. In this example, we need to integrate sine x, the square root of 1 minus cos x dx, using this substitution. So always start with your question. It seems a little bit strange writing it down when I've got it written right above, but generally you'll be reading it off your textbook and you'll need to actually write this down. So I'm just modelling what you'll be doing. Write down your substitution. Now let's integrate the substitution. So du dx equals, well, negative cos x differentiates to sine x. And so now you can see I've got du, and in fact at this point you could even cross this out and say like that. It's a cheeky little way to go from it being a 2-step process into a 1-step process. After a little while you won't be writing the dx down there, you'll be just holding off and saying du dx and just thinking about the dx, writing what du dx is, and then putting the dx on this side. So that way you've cut straight to being able to do this in one go. But as I said, if that feels confusing to you, just write du dx and then multiply by dx on the next line. Okay, now have a look at how that compares to what we've got over here. Well, we've actually got sine x dx here. So this part and this part together are du. So they're taken care of. So on the next line, we can say this part here, well, it's just the square root of u. So we've converted it into that. And at the same time, we could have thought ahead and thought to change it into this so that we can actually integrate it by just adding 1 to the power and then dividing by the new power. And remember, dividing by 3 over 2 is the same as multiplying by 2 over 3. That's a slightly easier way to do it. And then we need to add a constant. Now the last step, we've been asked to differentiate with respect to x. So we can't give an answer that's got u's in it. So we can tidy up by just substituting back in, and u is 1 minus cos x, and we raise that to the power of 3 over 2, add our constant, and we're done. Next example now. I've already written out my question and I've written out my substitution. Now I need to find du dx. Think to yourself, du dx is going to be -1. But as you go to write -1, you can say, hey, I'm going to now multiply by dx. So -1 dx or just negative dx is your answer over there. Now, having a look at this one, it's a little bit different. If I want to swap out my dx for du, I actually need negative dx, and I don't have a negative there. So I'm going to have to put a negative in and put a negative fixed factor out the front. And I think it's kind of handy that way to write your question down, leave a bit of room in and around the integral sign, so that if you want to put a fixed factor in, then you've effectively written your question, but then also written on it as well. So that if instead of being just a question, it's now your first line of working. Now, the other thing we don't have in this one, u is 1 minus x. So this part here looks like that. But what about the x? That's the part that's missing. So if we need to put in something for x, then occasionally you'll need to fiddle around with this to get it in terms of x. So quite simply here, adding x to both sides and taking away u from both sides, I can see that x equals 1 minus u. So for this one, I need to put 1 minus u in, like that. And now I can see that I've got my negative fixed factor out the front, the negative dx part, that helps me change into du, because -1 dx becomes the du, this part's become the root u, and this part has become 1 minus u. So just double check that you've got all of the parts there. Next, we need to get it into a form that we can actually integrate it. So we don't want powers like this. We effectively want this to be u to the power of a half, and we need to expand our brackets here. So we've got u to the power of a half multiplied by 1, and then we've got negative u to the 1 multiplied by u to the half. So that's going to give us u to the 3 on 2 du. Now we can integrate. We've got a negative here, so we've got to put the negative around the whole thing, and we've got to raise the power by 1, divide by 3 over 2, which is the same as multiplying by 2 over 3, and here we've got to raise the power by 1, that will be 5 over 2, and multiply by 2 over 5, and then add a constant. Now we can probably do two things at once here. We need to expand our brackets, which means effectively just changing the sign of both terms, and we need to sub back in what u is. So I've got -2/3 1 minus x all to the 3 over 2 minus 2, plus, I need to change the signs, don't forget what we're doing, 2/5 1 minus x to the 5 over 2 plus c. Now, that looks quite complicated and a bit awkward, but the process was actually quite straightforward, and I think you can see now that this is allowing us to do questions that we couldn't have actually done before.